So this one is paper 2 CR. Duration 1 hour 15 minutes. The diagram shows some pieces of apparatus A, B, C and D. Complete the table by giving the name of each of the apparatus. So the first apparatus is test tube. Apparatus B is evaporating dish. C is a measuring cylinder and D is a balance. Which piece of apparatus can be used to measure the volume of the liquid? So which apparatus can be used to measure the volume of liquid? A measuring cylinder can be used to measure the volume of liquid. Thallium is an element of group 3 and period 6 in the periodic table. The atomic number is 81. How many electrons are there in outer shell of atom of thallium? So how you will work out, how you will know that they mention it's group 3. So group 3 means it will have 3 electrons in the outermost shell. A thallium ion has a charge of 3 plus. How many electrons are there in thallium ions? So it is having atomic number 18, so there will be 18 proton and 81 proton and 81 electrons. It lost 3 of them, so it will be 78. A sample of thallium contains 2 isotopes. The table shows the mass number and the percentage abundance of each isotope in the sample. Give the number of proton and number of neutron in one atom of thallium isotope 205. So how many protons will be there? Because its atomic number is 81, so proton number does not change for isotope. The only thing which changes is the mass number. And how many neutrons will be there in isotope 205? So it will be 205 minus 81, that is 124. Calculate the relative atomic mass of this sample. How we can find the relative atomic mass of the sample? From the percentage of the isotope or the percentage abundance. So that's the percentage of the isotope, which is 30.8, multiplied by mass of the isotope, which is 203, plus percentage of the isotope, which is 69.2, multiplied by the mass of isotope, which is 205, and divided by, because the total percent is 100, so divided by 100. So using this formula, we will get the average mass of the two isotopes, which will be 204.4. The diagram shows a fractionating column used to separate the crude oil into fractions. The fractionating column is shown. Give a use of a bitumen and give a use of gasoline. So bitumen is used for road surface or road carpeting. Only road is not the full answer. It should be road carpeting or road surface. And petrol, the gasoline is used as a petrol or fuel for cars. Explain why bitumen is collected at the bottom of fractionating column and gasoline is collected near the top. So they have, because it's a fraction distillation, they have different boiling points. And why they have different boiling points? Because they have different number of carbon atoms. So at the top, like bitumen is having a higher boiling point, that's why it is collected at the bottom of the fractionating column, where gasoline is collected at the top, the cooler part of the fractionating column. So you will mention they have different boiling points. Gasoline and top side of column is cooler compared to bottom. That's why we collect the fractions with low boiling point at the top and high boiling point at the bottom. There is a low demand of some of the fraction obtained from crude oil. Cracking can be used to convert these fraction into more useful one. State the condition needed for cracking. So what we need to crack, we need a catalyst and a high temperature. So they're asking for condition, we need catalyst and we need high temperature. The catalyst normally which we use for the cracking, that is alumina, and the temperature is around 600 to 700. Dodecane, which is C12H26, can be cracked to produce alkane and two alkenes. Complete the equation, give the formula of two alkenes. C7H16 is given, so we are left with 5 more. So we can make certain combination we can make here, as we are left with 5 more. So example, if it is C3, it will be H6 and it will be C2 and it will be H4. Then this question is about some of alkali metals and their compound. When a teacher drops a small piece of sodium into a throw of cold water, she observed bubbles of gas. Give two other observations that would be made when sodium react with cold water. So when alkali metals reacting, the reaction is exothermic. So what we will observe, the sodium, the metal dissolves, the size of the metal will decrease, that's one thing. And because of a continuous fizz, the metal will float on the surface, like it will move on the surface. Solid size decreases, and it will float on the surface. Why we did not mention here a temperature? The question is what we observe. Observe means what we see. Because why we are not saying alkaline solution is formed, because we don't have indicator. Why we are not, the temperature will increase, but we are not touching it. We are not having a thermometer. That's why we cannot say that is our observation. If there in the apparatus, if there was a thermometer, we can mention that the temperature increase. Temperature will increase because the reaction is exothermic, but we don't observe that. Lithium reacts with fluorine to form a compound lithium fluoride. Write a chemical formula. Lithium belongs to group 1 plus 1, fluorine group 7 minus 1. So lithium fluoride will be LiF. Give a test to show lithium fluoride contain lithium ion. So tests for the lithium ion, basically what we can do, we can carry out a flame test, and lithium is giving a, we'll carry out a flame test, and with lithium it is red flame. Draw a diagram to show the arrangement of electrons in a lithium ion and fluoride ion. So lithium ion, because lithium ion they are asking, lithium is having 3 electrons, but it lost one of them. Like if this was a nucleus, lithium having 3 electrons lost one of them, so it will have only 2 electrons and with a charge plus 1. Fluorine belongs to group 7. It is having 7 electron, total 9 electron, overall 7 electron in the outermost shell. But it took one of the electron from lithium. So we use a dot and cross diagram. Fluorine first shell, it is having 2. Second shell, I should use a different symbol for fluorine. Second shell, it will have 7, belongs to fluorine, and one of them it took from lithium. That's why it is minus 1. The table shows electronic configuration of sodium and potassium. In terms of their electronic structure, why potassium is more reactive than sodium. So as you can see, potassium is having, like, the distance of electron from the nucleus for potassium is much greater as compared to distance of electron from a nucleus for sodium. So why potassium is more reactive? The electron in the outer, it's further away from the nucleus, so it can lose this electron easily. That's why it is more reactive. Case having electron further from the nucleus, less attractive forces or weaker attractive forces. And we use the term shielding effect, like when more electrons surround the nucleus, we call that as a shielding effect. So shielding effect of potassium is higher, so it can easily lose electron to react. This question is about the metal aluminum. Draw a label diagram, represent the structure and bonding. So you have to draw the lattice of the positive ion, and it should be compact structure, and the delocalized electron, but it should be a compact structure, not too much gap between the positive ions. Why the metal conduct electricity? Because they have free electron which can move within the structure. A delocalized and free electron, it can move. Free or mobile electrons are there, that's why the metals are good conductors. Aluminium is used to make a can for drinks. Give 2 properties of aluminium that is suitable to make this use. We are using it for can. So the 2 properties which make it suitable for this use: aluminium, like, it does not it resists corrosion, does not rust, and when you are making a can, like something, yeah, it is having a high like low density, that's one thing, so it is easy to lift, does not corrode or does not rust or does not react. And when something is used as a can, so it should be malleable as well, so you can hammer into shape. Aluminium is extracted from aluminium oxide by electrolysis. The electrolyte is aluminium oxide in a molten cryolite state. Why aluminium cannot be extracted by heating oxide with carbon? The reason why we cannot use carbon, because carbon is less reactive or aluminium is more reactive. The next part, aluminium is produced at negative electrode. The ionic half equation is shown. Why this is a reduction? You will remember from oil rig. Oxidation is loss of electron, reduction is gain of electron. Because it's a gain of electron, that's why it is called reduction. The ionic half equation for a positive electrode is given. So oxygen ion, when one oxygen ion is there, it will lose 2 electrons. But when 2 oxygen ions are there, they will lose 4 electrons, and it will result in a formation of oxygen gas. A student want to prepare sodium chloride crystal from sodium hydroxide and dilute hydrochloric acid. He does a titration to find the volume of hydrochloric acid needed to neutralize. He adds 25 cm cube of sodium hydroxide in a conical flask. He adds few drops of phenolphthalein as an indicator. He titrated with hydrochloric acid. Name a suitable piece of apparatus that measured 25.0 accurate volume. So what we can use a pipette for this, or a pipette. Give the color of phenolphthalein in sodium hydroxide. Phenolphthalein is colorless in acidic, and in alkaline it is pink in color. So originally it will be pink, then it will be colorless. Suggest why universal indicator is never used in titration. So why we are not using universal indicators in the titration? Because universal indicator shows a transition of the color. Like how I can identify when red color changes to yellow, yellow color changes to green. They are difficult to identify the continuous color change. So there is no clear color change, or difficult to determine the shades. That's why we are not using universal indicator as in a titration experiment. We use an indicator which show only one color change, like from orange to green is there, or when only specific color change. The student finds that 21.5 cm cube of hydrochloric acid is needed to neutralize 25 cm cube of sodium hydroxide. Describe what the student could do next to prepare a pure solution of sodium chloride. So student work out that this volume is reacted with, so 25 cm cube of sodium hydroxide reacted with 21.5 cm cube of hydrochloric acid. What he can do next? So he will mix the two solutions in the same proportion that is mentioned, and then he can use crystallization, heat, concentrate, cool, and describe how student could obtain dry, because the first part is what the student should do next to prepare a pure solution of sodium chloride. So what he should do, he should mix 21.5 cm cube HCl with 25 cm cube NaOH without indicator. And then how he can obtain the pure crystals from the solution: heat, concentrate, cool. Heat till the point of crystallization. Then you should cool the solution. then he will filter, then dry, heat and concentrate the solution till the point of crystallization. The student need 21.5 cm cube of hydrochloric acid with 25 cm cube of sodium hydroxide of concentration 0.8. Calculate the concentration for hydrochloric acid. So first 25 cm cube of sodium hydroxide is there, so we'll get the moles of sodium hydroxide by concentration into volume. The concentration of sodium hydroxide is given in the question 0.8 multiplied by volume 25, but that should be divided by 1000. We'll get the moles of sodium hydroxide. How many moles are there? 0.02. And then because we know the ratio between sodium hydroxide and HCl is 1:1, so the same number of moles will be there for HCl. And now we have the moles, we have the volume, but that volume is in, student need 21.5 cm cube HCl. So concentration is moles by volume. Moles are given, moles we calculated 0.02 as we use a ratio, and the volume is 21, so it will be 0.021. So we'll get this as 0.93 mole per decimeter. Question 7. Ethanol can be oxidized to produce ethanoic acid by heating with potassium dichromate. Name one other reactant needed for this reaction to occur. So we need oxidation of alcohol. We need an oxidizing agent. What else reagent we need? Because this oxidizing agent must be acidified. So as it must be acidified, so what reagent, what other reactant is there? It is having an acid so you can mention the name sulfuric acid because it is acidified potassium dichromate 6. Which color change occur during this reaction? This is orange. So when chromium is 6, it is orange. Chromium 3 changes to green. So it will change from orange to green. If it was potassium manganate, it will change from purple to colorless. When ethanol is burned in air, a complete combustion can occur. The equation for this reaction is shown. They represent the bonds as well. Using the bond energy, use the values, calculate the energy needed to break all the bonds and energy released when the bonds are formed, and calculate a molar enthalpy or enthalpy change for this reaction. So bond breaking, this side is a bond breaking and the other side is a bond forming. So 1, 2, 3, 4, 5, 5 CH bonds are there, so this should be multiplied by 5. One CC bond is there, one CO bond is there, and one OH bond is there, and 3 O double bond with C. So this will be 346 plus 5 into 412 plus 358 plus 463 plus 3 into 496. That will give us a bond breaking. So the total energy for bond breaking will come out 346 plus 5 into 412 plus 358 plus 643 plus 3 into 496. So when we add them, it will come out 4715. That's a bond breaking energy. Bond forming energy release when the bonds are formed. So one molecule contains two bonds. So two molecule contain four CO bonds. And one molecule contain two OH bonds, three molecule contains six OH bonds. So this will be multiplied by 6. So it will be 463 multiplied by 6 plus 4 into 743. This will give us the bond forming energy, which will come out 5750. So bond breaking minus bond forming is equals to energy change. The bond breaking was 4750. So bond breaking, the energy change and enthalpy change during a reaction, it's bond breaking minus bond forming. So bond breaking 4715 minus bond forming 5750. So the difference will be minus 1035. That is the energy change in this reaction. Ethanol react with methanoic acid in the presence of an acid catalyst to form an ester. The equation is shown. Name the ester form. When ethanol is mixed with methanoic acid, what is the name of ester form? The first name of ester is from alcohol and the second name is from carboxylic acid. So it will form ethyl methanoid. And then displayed formula of methyl ethanoid. So we will draw first for ester. Ester means C double bonded with O. And then the part which is the branch alcohol, it's 2 carbon at, and this one is having only 1 carbon. Remaining we will place the hydrogen. In a displayed formula we have to represent all the bonds. When this reaction takes place in a sealed container, the reaction can reach a dynamic equilibrium. Give two characteristics of reaction at dynamic equilibrium or equilibrium. The rate of the forward and the rate of backward reaction will be same, and there is no change in concentration. And no change in concentration of reactant or product. Methanoic acid react with sodium carbonate to form sodium methanoid. The equation is there. Calculate the volume in cm cube of carbon dioxide when 2.3 grams of methanoic acid reacted completely with sodium carbonate. So methanoic acid reacted completely with sodium carbonate. So methanoic acid is a limiting reagent. So first we'll find the moles of methanoic acid. Moles equal mass in gram over molar mass. So mass in gram 2.3 and the molar mass is 46. 2.3 divided by 46, this will give us the moles of methanoic acid. 0.05 moles. And then using moles of methanoic acid, we'll find moles of carbon dioxide by using a ratio. So the ratio from the equation is 2:1. So if we have 0.05, then we'll have x moles cross multiply. So 0.05 divided by 2, that will be 0.025. We have the moles. Now we need the volume. So we'll multiply by 24 the molar volume. So 0.025 multiplied by 24. But that will give answer in dm cube because moles equal volume in dm cube divided by 24. 0.6 dm cube decimeter cube. We have to convert into cm cube, so we'll multiply by 1000. So 600 cm cube. So this was the last question from paper 2CR of unit 4CH1.